Okay,
Can
sir. I am
Yes, sir.
yeah.
This is the full screen.
Yeah.
It is
Yes.
okay.
Go
Yes.
ahead, Mr.
Yes. Yes.
Said.
Yeah. Yes. My name is Mohammed Sai Jamal. I am pursuing PhD under Dr. Dilip Kumar Dilip Kumar from UGCDA's Consortium for Scientific Research Indore Center. My topic of presentation is evolution of structural and morphological properties of epitaxial film on MGO substrate during growth. These are the outlines of my talk. First, introduction. In this section, we will see first importance of MGO and discrepancy in the FEMGO system, and then the objective of my talks. After that, we will see the in situ growth of high quality epitaxial Fe film on single crystal MGO substrate. I will conclude the presentation. FEM geosystem is very important because of the various properties observed in this system. For example, Wi-Fi et al. Observe extend bias effect in FEM geosystem because of the formation of iron oxide at the interface. And other interesting properties have been observed. For example, perpendicular magnetic anisotropy in the FEM geosystem. These two theoretical report predicted a very large perpendicular magnetic anisotropy in FEM geosystem for a very thin film of iron. Even though the spin orbit coupling in FEM geosystem is very weak, they suggested that they suggested that the large perpendicular magnetic anisotropy is because of the hybridization between Fe 3D orbital and Ox 2B orbital. Another interesting and this is experimented by Duku large main FEMGO system. Another important properties in FEMGO trilayer interlayer coupling, where a very thin film of MGO is sandwiched between two magnetic layer, and these two ferromagnetic layer coupled by the thin MGO layer. And most interesting properties of FEMGO system is unusual magnetization reversal in unusual magnetization reversal and in plane magnetic anisotropy. Hubo et al. Observe unusual magnetization jump in Mach measurement with the azimuthal angle dependent Mach. So FEMGO system is very important as a application point of view, as well as as a research, because the FEMGO system is recently used in MTJ devices. Uh, FEMGO system also debatable because of the formation of oxide at the interface during the growth of Fe on MGO. Some report the few layer of Fe formation of oxide at the interface of MGO FEMGO. And some other report says that there is no formation of oxide during growth of Fe on MGO. So my objective is to study whether oxide formed or not at the FEMGO interface on ion beam clear MGO substrate. For this, we have used our in situ ultra high vacuum chamber, which has the following capabilities. For cleaning, we have a ion beam sputting energy up to 2.5 Kelvin, and sample temperature we can go from 50 Kelvin to 1200 Kelvin. We also have a for magnetization for magnetic characterization, we have a magneto-optical character and magneto-resistant. And for structure characterization, X-ray reflectivity, X-ray diffuse scattering along with the reflection high energy electron diffraction. And for transport measurement, we have also for probe resistivity. Before going to deposit load the sample into UHV chamber, first we have deposited AU gold of 13 nanometer as a electrode for transport measurement, and this is the just schematic of the reflection high energy measurement, where this is the read gun where the electron come from and strike on the surface, and reflected electron makes collected on the fluorescent screen and makes diffraction pattern and image captured by the CCD camera. Now, before going to deposit the Fe film on MgO substrate, first we have clean the MgO substrate. This is the read image of bare MgO substrate. One can clearly see there is only one spot with a huge background, which confirms that the MgO surface is not clean. Now, to clean the surface, first we have heated the sample at 550 degrees centigrade for 15 minutes. One can clearly observe there is several spots have been observed. Now, to further clean the surface, we have spotted by argon ion at 1 kV energy for 20 minutes. One can clearly see the spot are more visible as compared to previous one. Since we know that the iron being sputtered MgO surface may be oxygen deficient due to spitting. Now, to avoid this oxygen deficiency, we have heated again this substrate at 350 degrees centigrade under oxygen partial pressure obtained for minus 16 millibar. Now, after cleaning, we have started the deposition of Fe on a cleaned MgO substrate. First, when the thickness of MgO is very low, we have observed a broad spotty-like pattern, which confirms that the growth nature of Fe film is epitaxial, but at a very low thickness, the film in island form. That's why the broad nature of the spot. As the function as the film thickness increases, the body nature converted to sharp spotty pattern and elongated. And after 2.5 nanometer thickness, the elongated spotty pattern touches to each other and modulated like sticky pattern have been observed. One thing noted that there is no uh, extra spot have been observed between two modulated sticky pattern as marked by black line. If there is a strike spot between two static patterns, then there and one can say there is a formation of oxide at the interface. But what we have found, uh, if a FeO is formed at the interface during the growth of Fe, then there should be a one extra spot should be observed. And in case of Fe3 formation, there should be a a sticky extra sticky pattern observed, and same part Fe2O3. But in our case, during growth of Fe, there is no spot or sticky pattern have been observed. Uh, so, uh, so we can say that there is no formation of any oxide at the interface during growth of a Fe film. This is the transport of during growth of Fe film. This is a sheet resistant as a function of Fe film thickness up to 0.8 nanometer thickness. The sheet resistant almost constant. This is because of the at low thickness of Fe, the film in island form, there is no path to flow electron from one contact to the other. That's why the sheet resistant almost constant. As the
Mr. Jamal, you
thickness
have 2 more
increases
minutes.
beyond the 5 nanometer thickness,
Mr. Jamal, you have
yes,
2 more minutes.
as the thickness of yes, sir, okay, okay. This is the line profile of all the read images along the horizontal direction one, and this is the zoomed area of this yellow mark rectangle. One can say there is a slight change in the peak position of MgO and as Fe film thickness. This says that there is a slight change in lattice parameter of MgO and Fe film. And the Fe film grow according to relation Fe. This relation means that the Fe lattice is sitting on the MgO by rotating 45-degree. Now, to check the effect of the temperature on the Fe MgO interface, what we have
Hello. Yes.
Hello, Mr. Jamal.
Jam- Uh, Shahid
hello.
Jamal, share your screen.
Mr. Jamal. That is
Yes, sir.
Yeah, yeah. Share your screen, Jamal.
Yeah, yeah, yeah. Is it okay?
not it.
Not visible.
Is it okay, sir?
No,
Only your photograph is
No.
there.
no more. Yeah, yes.
Yeah. Okay. It is okay.
Yeah,
Okay.
double
You can
click
go
to
to the
enter the full screen.
conclusion slide probably.
Yeah, directly. Yeah, directly you
Okay.
just go to conclusion slide.
Uh, okay. Just a minute.
Okay, okay.
So modulate a sticky pattern transfer into sticky like pattern, and there is no extra stick or spot have been added. So we can say there is no formation of oxide at the interface as well as on the surface of FE. And same thing we have come to by X-ray reflectivity as well as the Mach measurement. When the Mach signal highly dependent on the thickness of the ferromagnetic layer. This black one is the pristine, and after red one is for after annealing. And there is no change in the signal height of the Mach. These also confirm that there is no change in SFE after running at 300 degrees centigrade. Now, on conclusion is that there is no formation of any oxide of Fe neither at the interface or nor on the surface even at 300 degrees centigrade.
Okay,
Okay, thank
thank
you,
you,
sir.
Mr. Jamal. Now your presentation is open for discussion. Yeah. The audience can ask the doubts and clarifications from Mr. Jamal. Any questions? If there are no questions, I think let us thank Mr. Jamal for the nice piece of work.
Thank
Thank
you,
you,
sir.
Mr. Jamal.
Thank you, sir.
Okay, sir.
Yeah, Dr. Ramesh, now you can
Yes,
take
sir.
over the. Yeah.
Okay, sir. Thank you, sir. First, I thanks to all to participate the ICON 2021. Uh, I I really thanks to on behalf of ICON to sorry sir, on behalf of ICON 2021. I thank to very much for our chairperson, Professor M. Vairamani sir, charging the session. Thank you to
Okay,
for
thank
that.
you, everybody. Thank you.
Yes,
Yeah.
sir. Thank you.
Thank you. Thank you.